Questions on the homework? Nothing? Yes. Yeah. Well, for instance, number. So where you're solving for something other than. All right, so pick one. All right, number one. All right, I need everyone to be quiet, guys, too loud. I had a couple people look at questions 1, 2, and 3, and they literally couldn't figure out what the heck was going on there. If you had remembered the video that I showed you, the demonstration, that's literally what's going on here. If you notice, it was a triangle, and on the 3 sides attached to the triangle was a square. Pythagorean theorem says the square of the side, well, that literally means there's a square on the side. Okay, so that's why you had a square and a right triangle. So on number 1, you had a square, and on one of the sides, you had attached a right triangle. On this particular one, well, it's attached to the hypotenuse. So the square is attached to the hypotenuse. That is your C. And the question didn't say what's the something about the triangle. It said, what is the area of the square? Well, the area of the square is always length times width or side squared. Either one, whatever's going on there, please stop. Okay. I'll go with length times width, even though all the sides of the square are the same. So if I knew one of the sides of the square, I would know all of them. Well, I can find the hypotenuse because we're given that this side is 15 and this side is 8. So I use the Pythagorean theorem to this, which will give me this side right here. Square that, and you got the area of the side, area of the square. So let's see, that would be 8 squared plus 15 squared is equal to C squared. How did I know it was C? Because it's the side that's opposite the right angle. Again, I asked you guys to stop, and you haven't stopped. Please stop. 8 squared is 64, 15 squared is 225. Those added together would be what? 289. Yep. Somebody with a calculator, square root of 289. What is it? 16.8. And since we want to know that the area of the square, any one of the sides, out. We're not dealing with that today. Any side of the square has the same value. So even though we solve for this side, all 4 sides are the same. And you just told me it was 16.8. So length times width, what's 16.8 squared? 16.8 squared. 282. Is that right? Okay. There you go. Done. I'm doing something. All right. Who gave me the square root of 16.8? Do that again. I was going to say, because that answer didn't match what was in the book. It's 17, not 16.8. There's no rounding involved. It's a perfect square. 289 is a perfect square.
Oh, I just marked mine wrong.
Right. So it's 17, and 17 squared is 289. There we go. All right. That's better. All right. Any other questions? All right, here we go. 1 through 21 all, very quickly. Number 1, we just did 289. Number 2 is 169. Number 3 is 400. Number 4 is yes. Number 5 is yes. Number 6 is yes. Number 7 is yes. Number 8 is yes. Number 9 is yes. There's a lot of yeses here. Number 10 is not yes, it's no. Number 11 is yes. Number 12 is yes. And number 13 is no. You should have had plenty of practice by that point with the Pythagorean theorem. All right. Finishing it up, the last ones. 14. C is equal to 2.24. It said round to the nearest hundredth. 15, C is equal to 10. It's one of those Pythagorean triples. 16 was 8.06. 17, A is 3.32. 18 is 13. 19, 11.24. 20, 15.41. And 21, B is 70, 70. That was it. Yes, David.
What did you say 19 was?
11.24. All right, make sure your names are on and pass them to the left. Pass them to the left. All right, second day of the Pythagorean theorem. Why are we doing 2 days? For those of you that just did your homework, like, well, this is easy. The rest of the chapter involves Pythagorean theorem. Rest of the chapter involves Pythagorean theorem. So it is critical that we can get this done. Homework today will be a worksheet. There's really only one thing I'm going to introduce today. It's just a different way of asking the question. So not anything really new today, just a different way of asking Pythagorean theorem. And a couple word problems. You're going to start to see a bunch of word problems involving Pythagorean theorem. So I'm going to get you very comfortable with word problems involving Pythagorean theorem. They're not that hard. They're actually pretty easy. There's a couple different ways it can be asked, but all of them are fairly straightforward. You're going to see this thing involving buildings and shadows and ladders and kites. Boy, they love those kites and buildings and ladders of Pythagorean theorem in math books. And shadows. All right, homework tonight is a worksheet. We got a long way to go. We do have a quiz on Friday. That's tomorrow. So the quiz will be on. Let's see, what have we done this chapter? What have we done? We've done square roots, and then we jumped right into Pythagorean theorem. So quiz tomorrow will be on square roots. Do you know your square roots? 2 different ways I can ask. The square root of a perfect square, the square root of 144 is 12. And then I can ask you what's the square root of 120. Okay? Therefore, you have to use that estimation technique as an extra one. Just put it on the print form. Okay? Lastly, I will put the Pythagorean theorem. So am I going to put that one where you have to actually do the long division and the estimation? The answer is no. Okay, so the things that will be on the quiz tomorrow will be square roots, both perfect and non-perfect, estimate to 1 decimal place, and then Pythagorean theorem. Yeah. You can bring a resource card. Yes, absolutely. I would highly recommend you put the first 16 perfect squares. All right, worksheet will be Pythagorean theorem worksheet. The quiz, no calculators on the quiz. No calculators on the quiz. You'll be fine. Hi, what's the square root of 10? Squeeze it. Squeeze it. 9 and 16. 16. Square root of 9 is
3.
Square root of 16. So it's somewhere between 3 and 4. Which one is it closer to? It's really close to that. So therefore your guess is, and you're done.
But what about the other stuff?
What do you mean the other stuff?
Yeah, like that divide by 2.
Did you listen to what I just said? Okay. I said that would not be on the quiz. I have a migraine and it's only 3rd period. All right. Yes. Yes. All right, here we go. Pythagorean theorem, second day. The Pythagorean theorem from Pythagoras. Theorem means something that is true, right? That's proven to be true. Says that if you have not any triangle, it must be a right triangle. But if you have a right triangle, that the two legs, if you square them and then add them, so the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. Those are a lot of words, right? All it means is find the hypotenuse. Once you find the hypotenuse, it's the side that is opposite the right angle. That is your C. The other two are your A and your B. You square all three numbers. You add together A and B, and that will equal the C value squared. So how is the problem presented to you? It's presented like this. They give you two of three sides. You plug the numbers in. The legs are the two sides of the triangle that make the right angle. That's 3 and 4. The hypotenuse is the side that is opposite the right angle. That is your C. So in this case, we're solving for C. We square 3, we get 9. We square 4, we get 16. 9 plus 16 is 25. It says C squared is equal to 25. To get rid of the 2, we don't use division. Jaden. We don't use division. The inverse of squaring is square rooting. So we take the square root of both sides. Pythagorean theorem, the last step is always take the square root. Okay? If life is nice to you, you get a perfect square. If life is not nice to you, you get a non-perfect square. And then we use the technique that I just walked Pi through. You're going to have to squeeze it, right? You're going to have to make a good guess. You have to be within 2/10 of the answer for me to give you credit. 2/10. What did you guess? So if you had guessed what, you would be wrong. 3.3, right? You didn't guess 3.3, right? 2/10 is plenty of wiggle room. 3.2 is a correct answer. 3.3 is not the correct answer. Okay? But I'm saying you will be within 2/10 if you know what you're doing. Give me a number. Give me a number.
48.
48. Squeeze it.
49.
36 and 49. What's the square root of 36?
6.
Is it closer to 49 or 36?
49.
Is it close or really close?
Really close.
So it's really close to 7. What's your guess?
Yeah. So you said
It's
between
really close. What's your guess?
7.
You went above 7. It's between 6 and 7.
6.1.
6.1's right there.
6.9.
Grab your calculator. Grab your calculator. Hey, somebody tell them what the square root of 48 is.
6.9.
What is it?
6.9.
You got the answer.
Yeah, but I'm saying like you said between.
That means if you had guessed 6.7, you would not get the answer correct.
Yeah, but like you said.
What did you guess?
I don't.
Did you get the right answer?
Yeah.
Then why are you worried?
Okay, no, I'm saying like good. Like since you said I have between 6.9 and 6.8.
Hey, please stop.
It's close to. It's like one off from 6.7.
So give me. I'm trying to show you that you know what you're doing. Give me another number. We'll do it one more time. Give me another number.
53.
53. Squeeze it. 49.
64.
Square roots.
7, 8.
Are you closer to 49 or you're closer to 64?
49.
You are closer to 49. Now remember, if you were halfway, the answer would be 7.5. Are you halfway?
No.
How do you know? Well, we could do some math. 49 to 53, that's add 4. 53 to 64, that's add 11. Oh yeah, you're closer to 49. Are you really close to 49?
No.
So it's not 7.1. What's your guess?
7.3.
That's your guess. Calculator.
7.3.
You guessed it right. Why are you worried?
Oh, I'm just saying that like.
You got the technique.
Okay, but.
If you follow what you just did, you will be fine. Do not think that you're off track. Now, granted, you can't give me the two numbers that it square or that it squeezes. We got problems. So having a good resource card with all your perfect squares up to 16 written on it would be good. All right. Sorry for the delay, folks. All right. So that was solving for a hypotenuse. Solving for a leg. Is everybody with me? Angie. Okay. All right. So here we go. Always look for the square first. Always look for the side opposite the square is the hypotenuse. So 13 is your hypotenuse. We are solving, depending upon whether you want to call this unknown side A or B. Doesn't make a difference. It's either A or B. Okay? We plug in our values. We square the numbers. This one involves, when you're solving for a leg, a little bit of subtraction before you take the square root. Solving for a hypotenuse, you add. Solving for the legs, you subtract. Subtract 144 from both sides. Last step is always take the square root. Hey, look, it's the same problem, just in different form. Kai, turn around. Okay. How could I write this problem without pictures? Like, I'm not going to show you the triangle. Go ahead.
Are you gonna give us you're gonna give us 3 numbers and everyone's stuff?
I'm only going to give you 2 numbers. But how are you going to know which one's the hypotenuse? You won't know. The third one's missing. So here's how it's presented. And if you looked at the sheet of paper, you already know this. Here's how it's presented without pictures. It'll literally say A is a number, B is a number, C is a number. One of them will be missing. It's the same problem. It's actually easier. Why is it easier now? You don't have to figure out what C is. It tells you what it is. In this case, it's what we're solving for. Okay? It's actually easier without a picture because, well, there's no way of screwing it up if they tell you what A, B, and C are. We plug the numbers into the formula. 64, 9. That's 73. All right. Do I dare do it a third time?
Yes.
Kai, squeeze 73. By the way, we got to take the square root of 73. Squeeze it. 64 and 81. Smack dab in the middle, 64, 8, and 9 would be 8.5. Let's see if we're smack dab in the middle. How many? You go from 64 to 73. 9. How many go from 73 to 81? How about 8? Do you see where I'm getting those numbers from? Hey, are these numbers close?
Yeah.
You're almost smack dab in the middle. You're not. Which one are you closer to? I'm closer to this. So it's not 8.5, it's 8 point. Do you understand why I said 8.6? If these two numbers were exactly the same, it would be 8.5. But you're a little bit over on this side, that number's smaller. You go to the number that's smaller. And since they're literally so close, I mean, the answer might be 8.57. We're going to guess 8.6. Answer?
8.54.
Okay. So how many did I say you could be off?
2.
You're 1 off. We had 2 wiggle rooms there. We could have even guessed 8.7. It's not 8.7. I mean, the real answer was 8.5, but we guessed 8.6. We're fine. You'll be fine if you follow the procedures. I have plenty of kids say, I can't do this. Well, I just proved to you could. Right? All right, Kai, you're done for the day. No more questions. That's too many. All right. By the way, do box 1. Go. Well, no. I understood that you're not feeling confident. This is the 3rd year teaching you. I know you like the back of my hand now. I do. You're the one that convinces yourself you don't know what you're doing, and then you get to the test day, you get a B or an A. Yes. Say again.
Mine are all right.
In a second.
Wait, what? This makes no sense. There's numbers at the bottom, there's numbers at the top.
There are 6 different problems there, my friend.
Wait.
What?
There are 6 different problems. Thank you, Christian.
Is there a specific
Yes, Kai.
Yeah, there's numbers there.
Who needs help?
Well,
Which one?
There's numbers there.
You gotta have numbers to do the Pythagorean theorem.
The numbers.
Kai, stop, just stop.
Use your
Guys,
brain.
Each length is a C and B, and then your Pythagorean.
Alright, so Mr. Friday, when I do like 5 times 6, it only comes up with like 3 decimal numbers.
What?
A and B are side legs, A and B are legs, and C
Down
and
here, see the word fix. Second, fix. You have it set on rounding to 3 decimal places.
Oh, so I could do 9? What?
As you put it to float, it will always put the right number. That means float. Now it will.
And if I go like to 0.
Well, if you have a problem that says round to the nearest tenth, and you can already have your calculator set to round to the nearest tenth.
Seriously?
What?
What? So this means give me every single decimal possible. 0 means no decimal places. 1 means the 10. And then you're gonna forget you have it in there, and then you're gonna wonder why you get thrown off.
For something I did.
For something I literally witnessed you do, yeah.
Literally where you were looking in the wrong spot where my eyes were going.
I was watching you.
I was looking.
You were not looking at me.
Yeah, I was.
Stop. Holler.
Make your eyeballs go in a big circle.
Drumming is
Big circle.
Why do you need to?
All right, now it's
Because I'm so sick of doing this.
better. Worse. Got a headache?
Yes. I just did this one.
Agreed.
What?
Let's give it 5 minutes. See what happens. I see half the class still working, half the class doing nothing. The half class doing nothing, you're done? Okay.
Good question.
Depends where you live, what that means. It can mean bad things in some countries.
No, I could. That's why I'm not. That's why I'm sitting here. I'm doing research for
Kai, work. Hey, worry about yourself. Anybody struggling?
These calculations.
Yeah.
Just work through the problems, Kai. Hannah, how did you escape not taking the test yesterday? Where were you guys yesterday? So I still can't hand your test back because Hannah hasn't taken her test.
No.
Bro. Yeah.
Hannah, calculator resource card, student advisement. I couldn't find, I walked around, I looked, I couldn't find where you guys were at, but you got to finish your test. Christian. They blew up 5 minutes after it landed. It was awesome explosion. I'll show you at the end class.
But you know. Oh yeah, they're going to the.
All right, here we go. First one, upper left. What do you got, Christian? That's what I got. Jackson, next one across the top. What did you get? 3.1, after you do all, notice the text here is very small. I got 3.2. What is it, the actual answer?
3.
That would be 3.2.
Technically, if you do 1 squared, that just cancels out because it's 1. So then you add.
I did that.
Wait, what? Why would you add 1?
You have to. It doesn't cancel. 1 squared is 1.
So then why would you add it still?
Because Pythagoras said that a squared plus b squared. He didn't say a squared and sometimes you add b squared. He said all the time you add b squared.
So you're telling.
All right. Jackie, third one. 15.6. After throwing in all the numbers, I got 6.6.
I got 6.63.
I got 15.6.
Jackie,
I did it wrong.
you subtract 100 from 144, you get 44. The square root of 44 is somewhere between 6 and 7.
Yeah, no, I added 144.
You added, okay.
So,
That would cause trouble. All right. Priscilla, what do you got?
I did the same mistake as Jackie.
Tell me what to do.
Well, you squared 7.
Tell me the whole thing. A squared plus b squared equals c squared. You don't need to tell me what the squares are, but you got to put the numbers in the right spot. Go.
Okay. A squared plus 2 squared equals 7.
Do you see the square? Do you see the square?
Yeah.
What side is opposite the square? What side is opposite the square? And there's a number there. That's your C. So
So is it 7.2 then?
I rounded to 7.3. Am I wrong? Is it 7.2 or is it 7.3?
I got 7.28.
That's 7.3. All right, here we go. Middle row. What do you got, Jaden?
I got 16.40.
That would be 16.4.
I got.
All right. Amber, last one. What do you got?
3.
What? 3? Let's see. Does anybody notice it's that one of those Pythagorean triple? 3, 4, 5. Look at that. If you had noticed that, you wouldn't have to do any work. But yes, 3 is the right answer.
Wait, huh?
It's a 3, 4, 5 triangle.
How'd you?
A is 4, B is unknown, C is 5. A squared plus B squared equals C squared. A is 4 squared, that's 16. C is 5 squared, that's 25. Subtract 16 from both sides, you get 9. The square root of 9 is 3.
Wait, why is there a pattern? Like it's 3.
Were you here yesterday and paying attention?
Yes.
You clearly know.
No, I know how to do that.
Who remembers the other one? It was 3, 4, 5. And what was the other Pythagorean triple?
4, 6, 3.
5, 12, 13. And any multiples of those. So take either one of these and multiply by 2 and you get more Pythagorean triples. Okay? Last one. All right. Enough of that. The other thing that we did last night for homework was this. I gave you 3 values and I said, will it make a right triangle? Will it make a right triangle? Throw that in the trash there, Jaden. Throw it in the trash. Ball it up, throw it in the trash. And then start doing, those of you that are passing that, the correct thing. What did I say yesterday about this? If it's a right triangle, which one is the hypotenuse?
The
The largest one, not the last one. The largest one must be the hypotenuse, if it's a right triangle. We're not even guaranteed that it even makes a triangle next year, or sorry, sophomore year. We take geometry. I will teach you whether 3 sides can even make a triangle. Remember, most of the time, 3 sides can make a triangle. Sometimes if those 3 sides can't make a triangle. Okay? We'll learn how you figure that out in high school geometry. But for right now, they're going to give you 3 sides. The question won't be, will they make a triangle, but will it make a right triangle? If it's a right triangle, then a squared plus b squared will equal c squared. So all you do is you find the biggest number, not the last one, not the first one, not the middle, but the largest one. What are you doing? Stop. Pay attention. Turn around. 20 is my hypotenuse if it's a right triangle. I throw all the numbers in and I would see if it makes it true or false. That's 400, that's 144, that's 100. It doesn't matter how you add those numbers, you don't get to 400. So no, this is not a right triangle. When it is a right triangle, the left side will equal the right side. All right, do your work and the rest of you stop messing around. 4 problems, go, box 2. Okay, if you're not going to pay attention when I'm talking, then I won't give you the benefit of an explanation. Okay.
Oh.
Anybody lost to get started?
It's still hurt.
Okay, I said we're gonna wait 5 minutes, see if it clears up. If it doesn't, then we'll go to the nurse.
Do you teach astronomy?
No.
So next year is going. Wait, do you have a master's degree in it?
No,
No.
don't need a master's degree to teach high school astronomy.
Have you worked at NASA before?
No,
Have you gone to NASA?
yes,
Well, have you seen
I was a tourist. That's not a major accomplishment. Instead of going to Disneyland for the 5th day, I said, no, we're going to NASA.
Wait, where is
Oh,
NASA?
It's just east of Orlando. So
Wait,
whenever you
you're-
go to Disneyland, you should take the 60-minute drive and go to NASA. Maybe you get to see a rocket launch.
I could have gone to NASA. I want to go to NASA. Can we have a field trip?
Saw one, that's cool.
Well, those are flies, like you see the plane. I know.
Yeah,
Can we go?
he's the what? Oh, nice.
Can we go to NASA as a field trip next year?
Okay, go over to four.
You don't get to take the strong because you're a freshman.
I'm allowed to go into the real space station.
Wait, so next year you start astronomy.
So,
What do we learn? Do we learn about stars?
yes, anything above our heads we'll learn about.
Oh, like
Black
black
holes.
holes.
Air, yep.
The ceiling.
Anything outside of this building above your head, we'll learn about.
Clouds.
Clouds, sure. Clouds affect astronomy. Weather affects astronomy.
Let's go.
Airplanes,
Is it only
we
one?
will learn about telescopes inside of airplanes.
Wait, so is it 2 classes or just one? Like, do you go through the same thing over and over?
Yeah, I just teach one class of astronomy over and over and over again. So you take it one time and then you're done.
What other classes are you doing?
Math,
What else?
math and astronomy, that's what I'm gonna teach next year. And hopefully for coming years.
You know what you could do for
Do this work, please.
You could do.
Do this work, I'm not
I
talking to you.
did.
All right, first one, upper left, Merrill, yay or nay? Yay. 3, 4, 5. Did anybody knows 3, 4, 5? All right, Jace, lower left. Right, that is a big fat no. Oops. Go ahead, winner, upper right. No, you gotta give me the answer.
Oh, no.
No, you gotta give me the answer. Give me the answer.
What?
Give me the answer.
Oh my God.
What?
Nay.
No, give me the answer.
No.
Do you understand what I'm doing?
Yeah.
Okay, good. All right. All right, go ahead. Abby, last one. Yeah, you're the only Abby here.
I thought you said they sound good.
They do sound alike. Anybody notice? What is this one? 5, 12, 13. Just double. Just double. All right. Last thing of the day is this. We love our word problems. Listen, please. Listen. We love our word problems, especially the ones that involve Pythagorean theorem. They only basically come in 2 flavors. This is one of the favorite flavors. It's called the ladder problem. I have no idea why mathematicians like this problem. I could make a much better one, but I keep it every year because this problem is, you see it all the time. The two favorite ones either involve a ladder or a shadow. Okay. There's another one that involves a kite, but it's basically all of these problems are exactly the same, by the way. You're going to have two things. They're going to make a triangle, and you got to calculate one of the sides of the triangle. There's a kite. Kite has a string. It goes up in the air. You drop a line down from the kite. It makes a right triangle. A building casts a shadow. Connect the top of the building to the end of the shadow to the start of the building. It makes a right triangle. When you put a ladder up to a building, guess what it makes? And not only just a triangle, it makes a right triangle. We love this one. Now, I show this all the time because some kids just can't picture this in their head. What do you mean a ladder? They think that the ladder goes flat up against the wall like this. That ladder falls down, right? Now, granted, that's a pretty steep angle right there. But in general, all ladders tilt onto the building, okay? And it makes a right triangle. So all you have to do is read the question carefully and make sure. And that's where the problems usually occur. Because the words that describe this simple picture sometimes are hard for some students to understand. The distance of where the ladder touches the building is right here. That would be this side, the left side. Okay? How far the ladder is away from the building would be the bottom. And the length of the ladder would be the hypotenuse. So where the ladder touches the wall is A or B. How far the ladder is away from the wall is A or B. But the length of the ladder is your C value. Smallies, you paying attention? Okay? Now we simply need to read it and plug in numbers. The foot of the ladder. Once again, some kids aren't familiar with ladders. Some ladders literally have feet. On the bottom of the ladder will be a movable object. It's called the foot. Okay? The foot of the ladder is right there. The foot of the ladder is placed 6 feet from the wall. Where does the 6 go? On the bottom. The 6 is going to go right here. If the top of the ladder, okay, nobody messes that up. If the top of the ladder is 8 feet up, the kids that make the mistake, they want to put the 8 right there. That's not what it says. It says if the top of the ladder is 8 feet up the wall, that's over there. How long is the ladder? The length of the ladder is going to be the hypotenuse. There are the numbers correctly placed. Abby.
So if the ladder was continued and it was parallel, what would that be?
Wouldn't make a triangle. Okay. And then we couldn't use the Pythagorean theorem. Okay. Okay. Okay, now we got to do the math. Let's see. 6 squared plus 8 squared is equal to our hypotenuse squared. You can give it any letter you want, including C or X. We do that math. Maybe some of you realize that's a 3, 4, 5, just in disguise. Okay. Can you see it? 3, 4, 5? Okay. If you realize that, you immediately can say that the answer is 10 before you do any work. But maybe you didn't recognize it's 3, 4, 5. So you do 64 plus 36 is 100. Square root of 100 is 10. Who's lost? Okay. You're supposed to be doing this. I see nothing. Second problem. Okay. Occasionally they like these directional problems. Never eat soggy waffles, yes?
Yeah, bro.
Does anyone not know what that means?
Northeast, southwest.
You need to be able to draw a compass rose. Why is it called a compass rose? In olden maps, the compass actually looked like a rose. Do you get where that looks like a rose? So for those of you that have never heard it, I will draw you a compass rose here in a second. It says John leaves school to go home. Draw a picture. Where is he coming from? Well, there's my school, LTA. He's going home. He walks 6 blocks north. Which way is north? Okay. There is your compass rose. It doesn't look like a rose. Okay. North, south, east, west. Never eat soggy waffles. Clock. Start at the 12 o'clock, go around clockwise. Never eat soggy waffles. So if you walk north, you're going in the upward direction. It says 6 blocks. Well, How long is that?
6.
It's literally 6 blocks. So it's a 6. Okay, the units here are blocks. Okay. Now he goes west for 8 blocks. Which way? He's right here. Now he goes left because you can't cut through old man McCraw's house because he's got that mean dog, right? So you can't go diagonally. You got to go north and west. Okay. So he goes 8 blocks because of the mean dog, and he finally gets I'm at home. The question says, how far are you away from school? Guess what? It's not 14. 14 would be the long way because you aren't allowed to cut through Angry Dog House, right? But if you could, that would be the shortest distance. Hey, you just made a right triangle, okay? You just made a right triangle. Yes.
So the numbers are the same as the other one.
So therefore, what's the answer?
10.
Notice it's another 3, 4, 5 triangle. So yes, if you notice that, and I do make a point of it, I'm just saying, math teachers love 3, 4, 5, 5, 12, 13. Okay? If you don't notice it, but you know how to solve the Pythagorean theorem, then it's no big deal. You get to the end, you're like, oh wait, that was an easy one. Why didn't I realize it? It's okay. It's not that much work. Are we okay? I didn't give you a shadow one. A shadow is a common one. A shadow one would look like this. You got a building. A lot of times it'll be a flagpole, and it says the shadow cast by the building is 100 feet. Unfortunately, 7th and 8th graders don't know where shadows are. So when it says it casts a 100-foot shadow, the student will say, "Oh, shadow, 100 feet."
No.
Yeah.
No.
It's on the ground.
What you have to realize is that shadows are on the ground.
How is that?
It'll say that you have a right angle. It'll say that the flagpole or the building is, I don't know, 20 feet. It'll say, how far is it from the tip of the building to the tip of the shadow? It's just a right triangle. I see it every year. All right. The last one that we'll do, I like this one because it exposes something that some of you don't know. That when you buy a television, you always buy it by its size. Like, I'm getting a 60-inch television. No, you're not. Televisions are measured diagonally because it makes them seem bigger. Donna's television screen is 20 inches. No, it's not. I'm sorry, 25 inches. This is a 25-inch television, but it's not. Because in reality, Donna's television, the length of it is 20. And the diagonal measurement, the measurement that's on the box, when you buy it, it says it's a 25-inch television. Manufacturers sell it because this distance is longer than that distance. When we think about the distance, we think that that must be 25. It's not. If you don't believe me, and you know how big your television is at home because you still have the box or something,
5-inch.
go ahead and measure it. Measure it from here to here. It won't be 75 inches.
Mine's 2
It'll be a
inches.
whole lot less. Okay?
Yeah, it is a lot less. 2 inches.
86 inches.
We can figure it out. All right. By using the Pythagorean theorem, by the way. All right. So it says, how big is the width of her television? Well, once again, it's a rectangle. Cut in half, it makes 2 triangles, and the 2 triangles are right triangles. So we simply throw that into the Pythagorean theorem. Remember, the side opposite the right angle is the hypotenuse. So the hypotenuse here is a 25. This one is a little bit less friendly because the numbers aren't so friendly. Okay. That gives me 400. That gives me, we did this one yesterday. What does that give me? 625. Subtract the 2, we get 225. And that is, for those of you that know your numbers, 15. So the width is 15. Very good. Question, Genevieve?
What is 50 box? Says like a 20 by 15.
The box will not say, in big bold words, it'll say that it is a 25-inch television. However, in small script, it'll say the length is 20 and the width is 15. That's what it will say. Okay. Cool. All right, that's it.
Choose the rocket.
Pack it up. Who wants to see a rocket explode? All right. Let's watch a rocket explode.
From the vehicle, getting ready for the ignition of the 3 reactor engines.
Where did it go?
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Abort.
Yes, it does.
All right, all folks, please triage alarms.
I can't see it.
So they tried it. They tried it once.
No, I can't see it.
Got the total test support.
What?
What do you think?
It's about direction.
Oh, my phone.
John, this was here on the webcast. You can see with the clock on the screen, we were down to 0.
They used my name.
Donovan, how dare
Donovan,
you?
my name. It's not to say.
Donovan, how dare you?
Sorry, my friend was on there earlier.
It's looking good. It's looking good.
Where is it going to?
It's trying to land.
Where?
Texas.
You see that? You see it?
Who?
Oh, it made it. Everyone's happy. And then 5 minutes later,
Ooh.
wait for it. Wait for it. Oh, that's bad.
Wait, what is that testing for?
Yeah, and other places.
So I'm confused. Didn't NASA already do something?
Yes.
So why did they want to go back?
So Christopher Columbus came to America. Why did he want to come back?
Because it's cool.
Same reason.
But they're saying
They
this
don't
is
know.
their-
They haven't released why it blew up. We don't know. I will say it landed really hard. It actually bounced a little bit. You see when it comes down, it goes boom. Right now, they're just building a really big rocket. They eventually hope that it can go to lots of places, Mars, the moon.
It's over there. It's over there.
All right, Donovan, that's it. Any questions?
Nope.
All right, see you tomorrow.